Okay, so hi everyone. Welcome to this video of digital image processing. That is the module 4 and module 5 of 21 CS63, where I will be covering the previous year questions, the textbook solved questions, as well as some of the very important questions which can appear in your VTU exam. Okay, so let's start without any delay. First question we have is, there is an image, you can say grid is given, which consists of all the pixels. You can see 3121, 2022, 1211, 1012. The question is, consider the pixel P and Q. If V equal to 1, 2, find the shortest path between pixel P and Q. So I have seen this grid. This is my P, this is my start pixel. I have to start from P and have to reach till Q, taking the combinations of 1 and 2, such that I get a shortest path. So how will I solve? Let's see. Suppose this is the same grid I have drawn again. Now I have to start from here, 1. My combination should be between 1 and 2, means I have to keep on tracing the path of the combination 1 2 1 2 like this. Okay, so starting from 1, I had to check diagonally, that means diagonally, or you can say applying all the n4 nd diagonal and diagonal neighbor and the mixed combinations. I have to check whether how can I get 2. I can see diagonally I get 1 2, then again check in all the 4 sides whether I get a 1 or not. I can check, yes, here I get a 1, followed by here again I get a 2, then again 1. Okay, so I can see this is my path from P to Q, where I have started from 1, with next combination will be 2, then again 1, then again 2, then again 1. You can see you can have more than multiple paths also, but at the same time you might encounter a question where you don't get any path. So for this, the path is 1 to 2, 2 to 1, 1 to 2, 2 to 1. So what is the shortest distance? 1, 2, 3 and 4. Okay, so next question we have is F and F2, two image grids are given, 137, 550, 75, 250, 150, then 50, 150, 125, 45, 55, 155, 250, 75. So what we have to do is we have to perform all the arithmetic operations. Arithmetic operations, what is the formula? G equal to F1 plus F2. This is my input pixel and G will be my output pixel. So let's start adding 1 plus 50, 3 plus 150, 7 plus 125. Similarly, keep on adding 5 plus 45, 15 plus 55, 75 plus 155. You get this as the answer. Now, the question is, if the number of pixels exceeds more than 255, you have to shift the value again back to 255 itself. That means no other pixel should have the value more than 255. That means I have a value of 400 here. This will be again shifted to 255. Okay, next we have is subtraction. Similarly, F1 minus F2. For F1 minus F2, 1 minus 50, 3 minus 150, we get this as the answer. Okay, but since we have got some of the negative pixels there, so whatever the negative values we have got, just convert them into 0. That means 0 0 0 0 0 7 0 0 0 0 0 75. Similarly for this multiplication of these images, G equal to F1 into F2. In this process, please don't do any kind of matrix multiplication. What you have to do is simply 1 into 50, 3 into 150, 7 into 125, 5 into 45, 15 into 55, 75 into 155. Same, you got the answer like this. Again, the values which have more than 255, just shift the values again, or you can, I should drop the range again to 255 itself. Okay, now again, G equal to F1 by F2, that is division operation. Nothing but you have divided all the F1 by F2, 1 by 50, 3 by 150, same way you got the values, but since it is coming in decimal point, you have to round it to the nearest integer. Rounding of nearest integer will be G equal to 0 0 0 0 0 0 1 1 2. Now remember one thing, for a grayscale image, 0 to 7 are the levels. Above 7, then you have to set it to 7 only. Here it was a color image. At the same time, if you get for grayscale image, remember it has only 0 to 7 levels. Any pixel who is having the value above 7, we have to drop it back to 7 itself. Next we have a question. Consider the image grid 130, 1167. This is the grid given. We have to calculate mean, median, mode, IQR, that means nothing but interquartile range, standard deviation and variance. How to do? This is my formula for the mean. Just add all the terms divided by the number of terms, 548 by 9, 60.89. For median, what we will do is you have to sort all the values such that median is the middle value when the values are in sorted manner. That means whatever the grid was given in the question, you have to sort that particular all the pixels 10, 10, 11, 50, 67, 80, 90, 100, 130. What is the median value? You can check like 1, 2, 3, 4, 5, 6, 7, 8, 9. That means 67 will be my median value. Okay, this is already studied in your basic mathematics, I guess. No need of much more explanation. Now what will be the mode? Which particular pixel has occurred the maximum number of times? That means 10 has occurred 2. That means mode will be 2. Next is interquartile range. Interquartile range will happen between Q3 and Q1. That is 75 percentile and 25 percentile. Q1 is this one. That means 10, 10, 11 and 50. Again, this median will be 10 plus 11 by 2. That means 10.5. Again, Q3 median will be 90 plus 100 by 2, 95. Then IQR will be nothing but difference between Q3 minus Q1. You get 84.5. Same time, how will you calculate variance? Variance will be equal to square root of summation of I equal to 1 to n xi minus mean whole square divided by n. So just apply the formula 1 by 9 into 130 minus 60.89. This is the mean ka whole square plus 11 minus 60.89 whole square. Continue till the end, you get the answer as 1711.79. Same time standard deviation will be nothing but under root of variance, that is 41.39. Next question we have is this image. You can see the image operations where you apply all the geometric functions. First, it is translation, rotation, and scaling. Let's look at the question. Consider the image at point 2, 2. You have to translate the image right by 3 units. That means right by 3 units in the sense the y will be 0, x will be 3. This is my matrix t equal to 1 0 delta x, 0 1 delta y, 0 0 1. Just put the value of delta x as 3, delta y will be 0. Then what is my equation? X dash equal to t into x. Just put this matrix again into 2 to 1. Perform the matrix multiplication here. That will be 5 to 1 transpose. Then scaling operation both x and y by 3 units. That means x and y both directions were scaling by 3 units. This is my matrix sx 0 0 0 0 sy 0 sy 0 0 0 1 homogeneous parameter. Followed by that, just put sx and sy 3 and 3 into this matrix 2 to 1. You get 6 6 1 as the answer. Now rotate the image in x axis by 45 degree. So let's see how. R equal to cos theta minus sin theta 0, sin theta cos theta 0, 0 0 1. Just put the value of theta as 45 degree. Then you get the value in this into 2 to 1 into this transpose. You get the value 0, 2.8281 transpose. So since this is a decimal point value we are getting, you have to round it to its nearest integer. So it is rounded to be 3. Next we have something known as horizontal skewing by 45 degree. For the skewing operation, I guess this was not there in the explanation part. The matrix for this is 1 0 0 tan phi 0 0 tan phi 1 and 0 0 0 1. Just put the value of phi as 45 degree. Then you get the skew value 1 0 0 1 1 0 0 0 1 into this image original coordinates. You get this as the answer 2 4 1 transpose. Now mirroring about x-axis, I've already mentioned one trick, that is whenever it is about the x-axis, that means for y you have to give a negative symbol. That means 1 0 0 0 minus 1 0 0 0 1 into 2 to 1. This is the original, you can say, coordinates. You get 2 minus 2 1 transpose as the answer. Following by that, we have shear in y direction. For shearing in y direction, that means you can say the shear of y will be 1 shy 0 0 1 0 0 0 1. Just put shy as 30. Then again followed by that, you perform this operation into this original coordinates. You get 62 2 1 transpose. Okay. Next topic is very much important, guys. It has been occurred many times in the model question paper as well as in your school exams, in your college internal exams also. First question we have is, what is convolution? So convolution, what happening is, it's process of shifting and adding the sum of product of mass coefficients and the image to give a center value. Let's understand this better by an example. So what we have is, we have an image that is f function, that is 0 0 2 0 0. We have a kernel 751. My objective will be to rotate the kernel and slide the kernel, okay, till it reaches the end. So how the algorithm works, first step will be, you have to rotate the kernel plate by 180 degree, then 0 padding is done. So let's see how the padding is done. This is my question 00200. You can see 00200. This is my original f value. Okay. Followed by that, I padded 2 zeros towards the left and 2 zeros towards the right. Now this is my kernel 157. Here I have rotated the kernel by 180 degree. You can see the original kernel was 751. Now what is my initial position? One thing you have to remember, guys, the output will be always produced in the center pixel. That means 0 0 0 0 0 157 is there, 1 into 0, 5 into 0, 7 into 0. That means answer is 0. It has to be produced in the center pixel only. You can see it here. Okay. Then again you have to slide the kernel or shift the kernel. Again, position after one shift, what it will happen? This 0 will return as it is. Now this 1 was here, it will come here. 157. Again same thing. 1 into 0 0, 5 into 0 0, 7 into 0 0. That means the net value is 0. Output produced will be 0. Position after second shift. After second shift, let's see. 0 0 0 and 0 was there as it is. Now 1 will come here. That is 1, 5 and 7. That is 1 into 0 0, 5 into 0 0, 7 into 2 is 14. So 14 will be produced in the center pixel. Okay, that means output produced is 14. Position after 3 shift. After 3 shift, what's happening? 0 0 0 0 0 2 0 0. Just slide 157 once again. You can see 14 has come here. 5 into 2 10, 7 into 0 0. That means output produced is 10. Just remember, guys, always the output will be produced in the center pixel only. Okay. Next we have is position after 4 shifts. After 4 shifts, what happens is, again slide the kernel by 157. This 14 was there as it is. This 10 was there as it is. 1 into 2 will come here too, because 5 into 0 is 0. 7 into 0 is also 0. The output is always produced in the center pixel. Now position after the next shift. You have to keep on performing the shift unless and until you reach the zero padding end. Now again in 5 shifts, what will happen? Let's see. Again slide the kernel by 157. Again 157 I shifted. That means 1 into 0. This 2 was as it is. This 1 into 0 is 0. 5 into 0 is 0. This 7 into 0 is 0. That means we output produced is 0, and for the shift, if you do it, then it will cross my particular range. So that's what here I should stop my iteration. Then what will be the final output? Final output will be 0, 0, 14, 10, 2, 0, 0. Okay. Now next is something known as correlation, guys. Correlation is nothing but the same operation, the same sliding of kernel we are doing, same like convolution, but since in convolution, one main thing what we did was we were rotating the kernel by 180 degree, but here we are not rotating any kernel. We'll take the kernel as it is. You can see same question I have taken 751, 751. Here, if I was performing a convolution operation, I was taking it as 157. But 157 is for convolution. For correlation, take the original one itself. Initial position, if we see, this is again the zero padding I have done, 751, 751. Position after the one shift, keep on sliding it. That is 751, 7 into 0, 0, 5 into 0, 0, 1 into 0, 0. That means output will be again produced as 0. Position after the second shift, again slide the kernel, 751, 7 into 0, 0, 5 into 0, 0, 1 into 2, 2. Just produce the output in the center pixel. Output produced will be 2. Position after the third shift. After third shift, what will happen? Again, do the same logic again, 751, 7. This 2 will as it is, 5 into 2, 10, 1 into 0, 0. That means 10 is produced, that is output produced is 10. At the same time, if you see, again you slide the kernel, 7, 2, 7, the same thing, 2 and 10 will remain as it is, but 7 2s are 14, 14 will come here, 5 into 0 is 0, 1 into 0 is 0, that means output produced is 14. Followed by that, we have the next shift, next and the last shift, that is 751. If you keep on sliding it further, you can see the output produced is 0, and further more sliding will help me to, let me to cross the range, which is done actually. So final output will be 0, 0, 2, 10, 14 and 0. These are the very important topics, or you can say important questions, which will come in your module 4 and 5 both. So let's discuss about some of the theory questions in detail. So this is the module 4 question bank. So guys, all the module wise question bank will be uploaded in the Google Drive. So module wise explanation I've also uploaded in the channel. Please go and watch those videos. Then only you can solve or understand these questions in detail. Okay. Like first and foremost, we have define image processing, write the need diagram and explain the image processing environment. You define image processing and we have a diagram also. Just go through it from the notes. Same time, we have various image processing applications as well. How will you represent a digital image representation? Then what is the different classification of images? We have a flowchart for this. Then explain how will you differentiate images on the basis of attributes and color. For color, we have those grayscale and then true colors, pseudo colors. Then what are the fundamental steps of image processing? How will you process an image? Then image topology, we have this neighborhood pixels, N4, N8 and ND. Then we have something known as connectivity. Connectivity, one question I've already solved. Then what is a matrix? Define the Euclidean distance, city block distance and chessboard distance. Classify the important characteristics of an image. It's already there in the notes. Then classify the image processing operations. Based on the neighborhood connectivity, everything is there in the notes, guys. Please go through the content very much properly and write everything with proper examples as well, okay? Because whenever the question comes like explain the arithmetic operation or logical operation, don't forget to mention the proper examples like how are you getting this particular answer. Fine, addition, subtraction already done in the notes. Then logical operations is also there. Then we have something as geometric operation. This I've already studied. Translation, rotation, scaling. I've solved one questions on this. What is interpolation? Already it's done. Back, forward and backward we have. Followed by that we have more 3 types: bilinear, bicubic, and one more is there. Just go through the notes. Next we have set operations in the images. Statistical operations, mean, median, mode. One question is already solved. Convolution, correlation. Just a few minutes back I have solved the entire question as well. This question I've already solved in the notes. You can go through it. This is nothing but your translation, rotation, this question. Next we have is the binary image, so dilation as well as erosion. Dilation and erosion is already covered in module 5 of digital image processing. You can just go and watch the video there itself. Then we have entropy. The same entropy question is also solved in module 4 of the digital image processing. Please go and check the video. Next, the mean, median, mode question is already solved just few minutes back. Mean, median, IQR, standard deviation and variance. Same convolution, correlation question has been solved. Just go through the solution once. Also guys, I would suggest please go through the textbook examples also, because sometimes you may get questions from there itself. So getting questions from there is a bonus mark for you guys also, because you already know what answer will be and how to solve that particular question. Okay, moving forward. Module 5, classification, image segmentation algorithms. We have different algorithms, scanning, edge detection, first order derivatives, then different kinds of filters and all. Just explain all those classification. What are the various stages of edge detection? You already know that is followed by that filtering. Then all those whatever that is, the classification step was there, right? Once flowchart, you have to mention, write that flowchart in detail. First order and second order edge detectors with proper this mathematical equation you should write. Explain robot operator and generic gradient based algorithm. Mention all the matrices, then all the equations along with the algorithm. It's already written in the notes. Same goes for pivot operator and Sobel operator. Don't forget to write algorithm, the matrix, the mask, and everything. It's very much important, guys. Template matching marks already it's done. 3 template matching masks, everything is given in the notes. Laplacian of Gaussian operator, one derivation is there, just go through it. And next is canny edge detection algorithm, it's also covered in the notes. Coming back to module 4 and module 5, guys, there are certain topics. If you check your syllabus, it says these questions are only for your internal assessment but not for SEE. So we can trust that, because obviously we don't have anything extra as such content. So these questions, module 5 question bank and module 4 question bank, if you study properly, then you are in a good position to score. These questions are not enough, I repeat. These are the important questions. These are not the exact questions, okay? So please go through each and every topics properly, and if you have any doubts, please let me know in the comment section. The notes and everything is shared in the Google Drive link. Go and access the drive. Prepare from now itself, and wish you all the best for the exam. Thank you.